Hello everyone. Today I will present EE3070 file presentation, which is my topic is the positioning of the ROV system. Let's talk about the background first. The background is current underwater robotic navigation relies slowly on the pilot operate camera, which is mainly focused on the underwater side. This really limited the ability to accurately localize and control the robot underwater. The traditional position system, like GPS, Bluetooth, lack effectiveness underwater due to the signal altitude. So that we need for the alternative tracking method that function efficiency in underwater environment. So that this project is evaluate the object detection with the RP LiDAR technology to provide the accurate above water positioning system for underwater robot. So it mean that our positioning is based on the project is based above the water position, above water positioning, which can cross-track with the underwater positioning checking. For the objective parts, this project will mainly separate in two big parts, which is the camera and the RP LiDAR development part. For the RP camera part, the objective are object detection function and the distance measurement with the data loading with the target object. Then the RP LiDAR part have three objectives. First is the data tracking for scanning. Second is displays the scanning in the mapping in graph or map for in the polar coordinate because the RP LiDAR mainly used in the RP coordinate way to present it. Also, is find out the target object because we need to corroborate the camera faces for the target object. So we need to find out the target object. For the combining of the system, we need to collect the distance and angle data from both camera and RP LiDAR program and display the target object location. For my handle part is the RP LiDAR and mainly is for the RP LiDAR. Also have some difference for the system combination for displaying the target object location. So for the technical background, first is the object detection, which using the technique for OpenCV, which is the AI machine learning method able computer to interrupt, analysis, and understand visual data from the visual. The OpenCV is the open source for the computer vision. For this project, we mainly using the YOLO V8 model by Ultralistic, and for the object detection sample, we use the COCO model for, also for the YOLO V8. For the RP LiDAR, we're using the RP LiDAR A1M8 model from SmartTech, which provides a 360 2D laser scanning for environment mapping. We support program libraries in different programming languages like Python and C++. Also compressed and factorized sensors suitable for real-time detection and navigation. So we also use the DB scan clustering for the system algorithm, which is the density-based clustering algorithm, also handling the noise, which can separate the separate point part, which is parameter-free clustering, which don't like didn't like the k-mean need to set the k value for the clustering. This clustering is based on the distance and the density, so no need to base it on the number of the parameter in point. The application widely used in separate data analysis, image processing, and normating detection due to its ability to differ clustering without prior knowledge of the number of clustering. So we can see the graphic at the left side. We can see the n is the noise, which is isolated from the other clustering group. So we can handling this k from using db scan instead of k-mean. The time phrase. Now the time frame mainly is my time phrase mainly is showed in the red box for the RP LiDAR doing the research and exploring the output and data clustering development and data collection and popping program development and test and improvement. For the system design, we internal the design and decided the target object distinction and test from a sample environment, which different from my groupmate is the file path I use the popping of show the both camera and RP LiDAR scan the environment technique to do it. Now is the system design. For the hardware of system design, we can show it in the right part. We use the set zero camera below the RP LiDAR, and because of the time phrase, we use the single camera, which is left camera, as the detection camera, and put it on the center, same as the RP LiDAR. Then using the RP LiDAR A1, which told before, which on top the camera, and the detection angle is same as the detection camera. Also, we can see it on at the behind have a blue float, which can balance and absorb the vibrate from the RP LiDAR, which can detect more accuracy. For the detection object, we use a ball fold on the water surface for object detection, which is deep color to make sure the camera can detect it. For the software, this is the flowchart for the camera program, which related the object detection by YOLO, and also will target the measurement. This the target object measurement, and record the target object distance and angle from the camera into the CSV file. This is the looping for this program to update the camera log time instantly. Then for my part is the RP LiDAR program, which included the RP LiDAR scanning, data loading, and the data popping by MATLAB. For the data logging, so we see on the right hand side, we start running the ARP program, start scanning, record the count map data, which is the location of the point surface, and then clustering using the DB scan and popping the polar coordinate graph for the time scale scanning and the data for the camera program, the CSV file, then will output to sheet for Excel for the environment and the combination with the other program. Then there will loop the time. So this is the RP LiDAR scanning, which scan for the. This is the setup which mainly focus on the COM3, which is the device manager part, and this is the scan for the CSV, and we can see it will do the looping function, and then we set the EPS value and the mean sampling value for the DB scan setting, and then divide it in the clustering group, and the below graph is the data looping for the RP LiDAR scanning. For the data popping, we can see the function. We can see the yellow part is the RP LiDAR popping, which is different color, and they have the negative one is stand for the noise, and the orange part is the camera, which is the camera display popping. So the testing environment, because I need to ensure the control the environment, so I push it on the drawer, which is the 50 times 50 cm, and put it in the center and target the blue blob. And for my prediction is have an inner surface of the drawer, which is the 25 cm, and capture the curved surface of the ball. So now is the demonstration time. Now we start the program first, then we start the camera program. We can see we have the movement, they have the scan instantly. But there still have the case for the RP LiDAR cannot scan some of the time. And we can see the detection is not very, the camera detection is not very fit, sometimes which further from the center. So this is the result. As the mentioned, this the object detection window and the popping window by RP LiDAR. Then this is the camera log saved in CSV format, which can easily to read and write for this file format. And this is the RP LiDAR format. The right hand side is the sheet 2, and the left hand side is sheet 1 for the clustering and this detailed information. So for the difficulty we shared on it is the RP LiDAR program may not output the whole scanning environment, and the popping cannot pop by real time because they have a time instant for processing and the data record. Also, the camera detection is not accurate as I mentioned before. So for the reflection, for the learn from this project, I learned the new scanning technology of LiDAR scanning and learn the object detection using ROV and OpenCV. Also learn the new method of clustering for DB scan. And also from this project, I'm trying to learn to use the other hardware model by the program. It's the new try for me from using the other technique such as the RP programming in the Python. Also learning how to collaborate and start the new and familiar topic with others, and self-learning to find a new way or idea. For example, using the MATLAB popping for displaying the scanning and find a new way of clustering to have idea to grouping the clustering point and the noise is new for me for self-learning because I'm seldom self-learning. For the further improvement for the project, the objective is to ensure the reliable capture and the processing of commitment environment data to enhance effectiveness in real-world application. For the inconsistent reading, RP for this model may not constantly capture the actual surrounding environment during the multi-scan. Also, the position cost of the limitation of the Python programming framework may not less powerful. Also, the model the further enhance its transit to a C++ programming environment using CMake for improve the performance and efficiency. Also explore the integration of a more advanced LiDAR model with enhanced scanning capabilities to change the older model and have a more accurate scanning with the supporting program or another. That's the end of my presentation. Thank you.